Hello folks, in this session we are going to cover thread synchronization. We're going to write a simple application which will sort of simulate say a visits counter on a website, right? When you go to websites it says your visitor number 5600 or something like that, right? So we're going to write a similar program. It's a simple console app, and one of the things you will notice in multi-threaded programming is when you read the data and when you update the data, uh, there could be other threads that are coming in. So you read say number 5 and 5 more threads come in between and they have gone to 6, 7, 8, 9, and you read back the data and now you got a 9. So will have a situation where you may have a consistency issue or an atomicity issue, right? So what we will do here is we will write a simple example, show you the issue with race condition, and then how can we use synchronization blocks uh, to make sure that each thread sort of gets the consistent data. Okay, so let's start here. To create a new class, let me call it synchronized thread. I'll have a main here. Okay, so let's assume that there is a visits. So I'm going to create a class, say visit, in which I'm going to say public static long visit equal to 0. Okay. All right. So the idea is that you will be able to access it from uh, any of the threads. Okay. Now in here, since we are going to make it multi-threaded, let's go ahead and extend thread, and then we have to override our run. So I'm going to do is public void run, and in here I am going to increment the visit. Okay, so one of the first things I'll do is I will do a visit dot visit plus plus, and I want to type out dot print line. I will do visit dot visit. Okay, now I'm going to do a loop here and essentially create a bunch of threads. So here let me go ahead and create a loop. Do 25 threads. And I am going to say thread t equal to new synchronized thread and t dot start. Okay, looks good. Let's run it, see what happens. Let me do a print. So you see it's coming up with some crazy stuff, right? It says as if 6 is the starting point, and then it has another 6 and a bunch of 6s, and 11 6. So it doesn't quite make sense, right, what it is doing here, right? So it almost seems like by the time we would have done the first print, about 5 or rather 6 uh, threads would have come in and already updated. So there's a lag between this and this. Between this statement and this statement, there's a bunch of guys coming in and doing their updates. Okay, so obviously if you are visitor 1, and you will be showing 6, the other guy will also be showing 6, etc. One thing is visit is okay. So fine. So 24 because you're starting from 0. So at the end of it, it will catch up, but obviously it is not good information. So let's run it again. And this time we are getting something else. You run it again, you get something else, right? So obviously this is not a good situation. So what is happening is between this guy and this guy, there is other activity going on. So let's assume we are just doing a simple thing here. If you have a bunch of code and you're taking data from it, you're doing some manipulation, you're going to write back, you can have a serious problem if your variables are changing that way. Okay, so again, you obviously have to have a different strategy. You should not be putting large synchronized blocks, but in case you need to, this is the method. So I will say synchronized, and I'm going to synchronize this visit. Okay, so I'm going to say visit class, and I'm going to tab this over. Let me save. And now if I do it, you can see that you have a lock essentially on the object. So you issue this, then you issue this, and then the lock gets released. So between these two guys, there's a lock on this object. So somebody else cannot come in while you have issued this and you're going to read back that variable for this statement. Nobody's going to come in the middle there and change the variable on you. Okay, so that's what's going on. So if you issue it again, you get the same results. Now if you need synchronization, you can also do synchronization based on synchronized this. Even within a class, if you have certain areas of code you want synchronization, you can do it. But for our example, we really have no code here. We are basically dealing with a simple static class like a counter. So this is the method. Okay. Hopefully this is helpful. We'll continue our series and we will post the next video shortly. Thank you.